Thank you all. Thank you, Dan. It's great to be here. For me, this is, I don't know about for you, but this is the first thing I've done since COVID started. Okay, so back in 2000, when was pre-COVID? 2019. I was doing like a talk a week, sometimes two, sometimes three. This is the first in-person thing I've done in 2.5 years. So we'll see how this goes. All right, so I'm going to talk about the future of AI, creating value at the convergence of emerging technologies. And so you'll see what that means in a minute here, but going a little bit back to what Dan was ending with there, the fundamental message at the end of all this will be that the future of AI is really about us communicating what value this brings to people and removing the fear factor that people have around AI. And I gave a talk in a series of talks in New York City a few years ago, and the whole idea was just to introduce people off the street to data science. Okay, so I had a friend there who just knew how to get people just to come in. And all these people just came in, right? And we gave them donuts and coffee. And I had a 4-hour presentation. And they stayed the whole time. And these were people who were absolute newbies in the field, right? So at the end of the session, we asked people to just sort of give us some feedback. I said, that's the only cost for the event. Give us some feedback. And one person said, she said, I learned today that data is not a 4-letter word. So from that day forward, I think that's sort of my tagline on most things. And so AI is not a 2-letter word. Okay, it's really about something much better than that. It's about creating value from data. So I say that AI there's really nothing artificial about it, even though that's the A in AI. But I think there's a lot more things that we can think about A meaning, automated, accelerated, actionable, assisted, augmented intelligence, all these other things that we're trying to do with these algorithms and these data that we collect. We're trying to augment the human experience, the human work experience, the human life experience, assisting people in their work, accelerating work. These are the things that we're really trying to accomplish here. There's really nothing artificial about value creation for business and for personal lives. So the outcomes we're looking for are not these artificial outcomes. It's really about taking data all the way through that insights discovery phase where we actually can learn what best decision we can make and what best action we can take in order to create value. So I like to describe AI as sort of 3 very broad categories. Okay, yeah, this is very broad, so if your favorite application isn't here, it's probably, I could just squeeze it into one of these. Image understanding, language understanding, and context understanding. That is understanding the context in which you see and hear and your sensors are telling you stuff. Okay, so that context understanding enables that next best action, next best decision. So very quickly here, and I have a lot of examples in this talk, and they only gave me 12 hours to talk, so I'll see if I can, oh wait. Oh, sorry, that's not what they gave me. Okay, so some of these will go fast, but image understanding, you certainly understand computer vision, I presume. So understanding what's in an image, what's in a scene, what's in a video. But the great thing for me, as a person who my entire life has been data, born and raised astrophysicist, worked at NASA 20 years, always on data systems for NASA satellites. Okay, so I was doing data by day as a NASA scientist, data by night as an astrophysicist, so it's always about the data. And so one of the things we were doing with those data systems is helping scientists find the data they need from all these different satellite data sets that we were collecting. And so what we can do now is we can start using AI to tag diverse data sets like images and videos, and then the next slide, language, that is tagging them with the content and actually creating a digital library, a searchable library of things that are unstructured data. Okay, so we can certainly do that with images now. And you actually can see that in some of the search engines, major search engines. Now, when you search for particular images, sometimes you can search, clearly you can search for words that describe the image, but there's actually words in the image that can be searchable now. All right, and same thing with videos. Videos can be queued up to the spot where that particular thing you're looking for is there. Okay, so these are really powerful examples of using image understanding to improve work experience and our life experience. Certainly language understanding, similar sort of thing. Unstructured data, the majority of the data in the world is not in databases, that's in some unstructured form somewhere. How do we make that searchable and usable, specifically for business users, just common business users who don't have degrees in data science and AI, who aren't doing data science and AI as their profession, they're just trying to do business. All right, so if you can start labeling documents of all kinds, okay, reports of all kinds, online reports, marketing reports, consumer reports, whatever it is, summarizing the topics, even emerging topics, trends in topics, even sentiment of the document, or how do people feel about this stuff. And again, you can start tagging these digital libraries to make them searchable and usable. And not only that, you start extracting other things from documents, including numerical entities, okay? So it's natural for us to say, yeah, well, numbers, right? Well, yeah, but if it's embedded in a document, can you extract numbers like from business reports and actually know what those numbers represent and then insert those into a structured database and then actually start enabling business users who are very familiar with things like SQL to start querying a document collection in the same way they would do an SQL statement against a regular database. Just amazing things are now becoming possible. So what is context understanding? Well, this is, for me, it's just another word for metadata, okay? So metadata is other data about your data, okay? So your data might be one word. I'm interested in astrophysics. So I would show you a pretty picture, okay? That pretty picture is like a 10 megabyte file. So my metadata, which is an image, is much larger than my data, which is the word astrophysics, okay? So a lot of times we think of metadata the other way around. It's some kind of short description of a big thing, but it can also be a big thing that represents the small thing. But it's just other data about your data, okay? So that other data could be just data that occurs at the same time, okay? That's sort of contemporaneous data about your data. Like what else is going on when this customer is doing this shopping? What else is going on in that environment, where they're having this experience? Okay, they might be at a shopping mall, they might be at a sporting event, they might be at home, they might be on vacation, they might be at the beach. Okay, so location and time then become relevant to particular types of things, certainly in e-commerce. So I like to say data is really a space-time continuum because there's other data that's at the same place in data parameter space. And we're all familiar with things like that called recommender engines, right? People who bought this book also like that book. People who like this movie also like this movie. Okay, so there's a data parameter space. So time and space are just 4 of the dimensions in our data space. Okay, there's nothing special about our data space. We have time, we have location, and we have all these other dimensions. So it's other data that's occurring in similar to or in that same area of that data parameter space. And that context gives us understanding about what's going on around this thing in order to enable that next best decision, next best action. And I have a little graph there as a graphic there that highlights graph analytics. One of my things I like to say to people is that William Shakespeare was a pretty good guy, and he had this great quote. He said, "All the world is a graph." Oh, wait, I'm on a stage. He actually said all the world is a stage. But what is a Shakespearean play? But it's about entities and their relationships, all right? That's what graph analytics is. It's about entities and relationships. What is the world? The world is about things and their relationships. So really, the natural data structure of the world is not rows and columns, but graphs. So really, graph analytics is the way that you connect all these dots in these multidimensional parameter spaces to find those insights, the things that are connected across the graph, all kinds of power in graph analytics. So some people say data consumes data. I just like to say AI devours data. AI devours data, all kinds of data, okay? And then you get that value the more data you consume. And you're going to see slides with lots of words here. I'm not sure if they're going to share these slides. I usually share my slides on Twitter, so if you follow me on Twitter, you'll be able to see them there. If you don't follow me on Twitter, you may leave the room now. Anyway, never, just kidding. So the talk today is about these emerging technologies. So which ones am I talking about? Well, this is just an example of some emerging technologies. And of course, AI lists right at the top there. We got 5G, robotics, drones, deep learning, virtual assistants, machine learning, VR, AR, immersive realities, metaverse, hottest topic of the year in this field is metaverse, immersive realities, natural language processing, Internet of Things, digital twins, quantum computing, and so on. So I like to say that all these things are driven by data, enabled by data, powered by data, and lead to value and jobs from data. So it's all data-driven, data-enabled, data-powered. That's why we call them digital technologies, right? Because it's digital, okay? Data-driven. Okay, but what's really pushing this frontier forward, I like to think it's this AI. It's that ability to augment our intelligence, assist our intelligence, accelerate our intelligence through operating these different technologies in our work, in our entertainment, wherever it happens to be, with the power of AI. It's really moving this frontier forward. Now, I just gave a talk similar to this a couple mornings ago to folks in India. Now, I didn't travel to India. I got up extremely early so I could speak to people in India time. And I don't know if anyone from India here? Why do you have half-hour time zones? That's okay. We'll talk about that at the coffee break. I don't understand half-hour time zones. You tell someone you're going to talk to them at the top of the hour. Well, it doesn't work when they have half-hour time zones. Anyway, so I was talking about this, and one of the themes they wanted me to talk about to that audience was there's a lot of startups in the room at their end. Not in my room, I was just in my home office. They wanted to know sort of like what kind of ideas do they have about using AI to maybe generate new businesses, new startup ideas, these kind of things. And I told them, I said, well, just think about combining some of these things, right? So combine AI with drones, or combine AI with drones with computer vision, or combine AI with drones with natural language processing, so you can do a command. Okay, so just pick 2 or 3 of these, 2 at a time, 3 at a time, 4 at a time. So start combining different technologies here and create a business around that. All right, so if there are 26 things, actually it's not 26, but it's close to, but I did the math for 26. If there were 26 things, there's 26 factorial ways to combine them. You know what 26 factorial is? 26 times 25 times 24 times 23, right? So you choose the first one, there's 26 choices. There's 25 choices for the second one, 24 choices for the third one. Okay, so you can start combining 1 at a time, 2 at a time, 3 at a time, 4. Well, if you look at all the possibilities, 26 factorial is a number like 10 to the 26th power. So we have room in our world for at least 10 to the 26th power new startups. So get busy. Okay. So I'm not going to talk about all those, and I'm not going to talk about too much about convergence specifically, other than how AI fits into all this, because that's the major convergence factor I'm talking about today. So I'm going to talk about these particular topics, AI, of course, and then robotics, drones, AVs, AR and VR, immersive realities, 5G, Internet of Things, which I like to call the Internet of Context, sources of data contextual data about our environment, sensors in our environment that are collecting contextual data. So I like to call the Internet of Things, those sensors collecting data, as an Internet of Context. And then I'm going to end with this event science in the dynamic data-driven application systems. So AI, of course. So one of the common things that you're going to see in all these slides, as I emphasize, certainly in the green-colored font, that's what I tried to do here, is the focus on the edge. Okay, so data at the edge, and we're trying to push our intelligence to the point of data collection. So I give a few examples here. So for example, something as trivial, you might say as trivial, but just gives an example of a postal code reader. Okay, if anyone's ever taught or taken a machine learning course, you probably did that problem set or gave your students that problem set of digit recognition, right? So you have some images of numbers. And that's the first hurdle for students here, right? Because, oh, it's a number, I can see that number. Yeah, but to the computer, it's just a rasterized bunch of pixels. How does the computer recognize a number? Okay, so postal code readers know how to do this. And it has to be done millions, if not hundreds of millions of times every single day. It has to be done at that moment. You can't send it back to the cloud and compute on this particular envelope. Is that a 1 or a 7? Okay, no, it's got to happen like that. Okay, so there's all kinds of ways that we have things that are operational systems that have to decide at the moment that the data is collected what to do with it, how to triage it, how to disperse it. Okay, so we see that in email spam detection, disease detection, maybe not quite as real time necessarily. Location intelligence. For example, you're walking down the road and I like pizza, so my app knows I like pizza, and there's a coupon pop up on my app as I walk down the street near this store where the pizza is on sale. Well, if that app shows up 15 minutes later and I'm in some other part of town, a lot of good that does. All right, so we got location intelligence, online product recommendations, again, in the moment. So all these things need to happen real time. Fraud alerts, good example there. Anomaly detection. Lots of examples of AI using edge data to inform and initiate actions. Okay, so robotics is basically, again, it's some kind of device that moves and reacts to sensory input. Okay, so again, this is an edge device most of the time. I mean, like the little vacuum cleaner that does your floor, or a robotic assembly plant, or deep space exploration or deep sea exploration, automatic inventory by robots in warehouses and so forth. Even the prosthetic arm, you see an example in the image there. I mean, that has to be like, you can't, like, again, go back and compute which finger do I need to move now. I mean, it's got to happen in real time. Okay, so robotics are devices that move and react to sensory input, edge data from sensors in real time. So drones, I like to say, are nothing more than flying robots. Okay, now drone can have a pre-programmed flight schedule. Okay, so there's nothing AI about it in that case, but it could be AI if it's used in, for example, a disaster response, or there's a lot of work using drones in construction, big construction sites, oversight of how the construction's going, if there's safety violations or other issues in large construction areas. And so so the drone has to be sort of have enough intelligence to know how to see and find the particular things it needs to see. Okay, so a lot of applications of drones for fun and serious applications. Autonomous vehicles. Perfect example, another sort of a moving robot. Okay, it's informed by data at the edge. And of course, the sensors include multiple things like cameras, radar, LiDAR, these types of things. It has to happen in real time. Now, I'd like to focus on AVs for a second here for several reasons. One is there's multiple data sources. It's not just the camera in front of the car. It's the ranging data that comes from the LiDAR and the radar. Okay, and there's also the contextual information in the environment. That's very critical. So here's a case where context is extremely important. For example, if you're driving down the street and you see some children on the side of the road playing with a basketball, for example, in a residential neighborhood, for example, you might imagine that it could be dangerous if I drive too fast past those children. I hope you think that way. Should slow down, because what if that ball bounces in the street? What if the kids run into the street in front of you? All right, so if the self-driving car was only looking at the data in front of it and not the contextual environment in which it's operating, that would be a very unsafe situation. Okay, so you need that contextual information. Time of day has to do with other things. For example, there's a sign that says school zone, but the school zone is only operational at certain times of the day, not at 2:30 in the morning. Okay, so, hopefully. And so contextual information is critical. Multiple sensors is another aspect of this. But the third aspect I want to talk about using this example is the importance of that real-time edge detection, edge computing. Because you can't afford to have your sensors, many sensors in your car, send the data back to the Amazon cloud, wait 15 minutes for the car to decide to put the brakes on. No, it has to happen right there in the moment, right? So you need edge computing, edge intelligence at the point of data collection, not sometime later. Okay, so there's a lot of things that you got to get right in order for this particular system to operate safely in our world. So AR, I like to say, is basically you're still in your real world. It's augmented reality, but it imposes or overlays, I could say, superposes information, content over your visual experience of the world. Okay, so that's truly in the edge. For example, if I hold up my smartphone in a store and I'm trying to find where a particular item, and it has to know that I'm moving it around. Or if someone is getting a disaster response situation, and they, for example, in a flooding situation, as shown in that image near the bottom there, they need to know where, for example, if there's down power lines. So as they're moving through that environment, they need information to be fed in real time and react in real time. Okay, so they're not in a virtual world, they're still in their real world, but the data is overlaid to augment their experience, to improve their experience, make their experience safer and better. And I love the example in the bottom right corner. Person goes to the store to try on clothes without actually trying on the clothes. They see themselves, not someone else, not a model. They see themselves in the mirror, the augmented mirror. They see themselves with the clothes on that they're choosing to decide whether to buy. Okay, so that's a true AR experience. You see yourself in something that you're actually not wearing, but it looks like you're wearing. So I like to think of also some of the applications of this for security. For example, in airports or big entertainment or sporting events, shopping malls, where you can detect, for example, behaviors in a big crowd and identify something in advance to be able to address it as fast as possible using computer vision, facial emotion detection, or whatever. For example, I remember a story didn't actually happen this way, but could have happened this way. You might remember several years ago the Boston Marathon bomber who set off the bomb during the Boston Marathon. Okay, so a couple things there. If someone was seriously injured, you could if you had like a surveillance camera, again, surveillance sounds like an awful word, I get it, but at the same time identify maybe a person who's in shock, because and this big crowd who might need immediate medical attention. The AI can find that person. Okay, but you don't want your first responders in some virtual world. You want them physically there, so they're able to do that. At the same time, you also get perhaps find immediately the bomber, because the person who's walking in a very straight line quickly from the scene might be the person who was responsible. Okay, everyone else is like, things like this. Anyway, so there's applications in security, and I'm just being a little simplistic here, but there's a lot of applications of AR. And then we move to the actual virtual world, where now you're embedded in a space. And the one example that I'd sort of like is the one that's here in the top right corner, which is your data space. And NASA has had caves for many years, these audio-visual environments where you actually can go and play with your data, explore your data, walk through your data, move through your data, bring up different dimensions of your data, and actually go into your data space to look for things. Okay, so so this whole world of metaverse is sort of like all over the place in the things that I've been reading yesterday. So this is truly data-driven, because you've got to use data that goes into designing and showing you the world you're in, but also it's not only just data generators, if I want to say it that way, that it has, if I'm going to walk through a door, and I actually did this, I had this VR experience when I was at Booz Allen. They were showing me this VR training program they used for the Air Force, where they were training Air Force airmen and airwomen to load the big cargo planes. Okay, and if you get the balance wrong, it's pretty seriously bad for the plane. You got to get the balance right. They're loading heavy cargo into these big cargo planes, and so they don't actually physically do that in a real plane first. They do it in a virtual plane. Okay, so I was in this virtual world, sort of seeing this take place, and then they had me walk over to the door of the plane. Once the plane was airborne, and this is a virtual plane, right? The plane went airborne, and I walked over to the door, and they opened the door. And I could look out and see the wing and the engine, see the wingman the jet flying along the wingman. Look down, and I have a fear of heights. I literally felt sick, like I was going to fall. Even though my brain knows I was in a virtual world, my body, my mind had a problem with me looking out the window 3,000 or 4,000 feet down in this virtual experience. Okay, so training exercises in this virtual world, all kinds of things happening in the metaverse, in the virtual world. So the data generators need to know that I walked to that door and certain things, but also they're data collectors. How are they data collectors? Well, if I touch something, it has to know that I touched it. If I want to move that book or open that book in the virtual world, it has to know that's what I did. Okay? So it has to collect data from me. It has to sense what I'm doing in order for it to be a reasonably real experience, instead of just walking through like a museum looking at things. Okay, so maybe your virtual world is nothing more than a museum, and you walk around looking at things. So you're looking at someone's $30 million yacht that they sold as a non-fungible token, if you know what I'm talking about. Okay, but maybe you want to interact with that world, and so you have to have edge collection, data collection from you to know what you're touching, what I'm looking at, where I'm going, what door I'm walking through, and all that kind of stuff. So it's all about the data. Moving along, 5G. All right, 5th generation wireless. This is going to enable the movement of all this data. Remember I said a few minutes ago that your autonomous vehicle, you don't want to send the data back to the cloud, wait 15 minutes to decide, oh, there's a child in front of your car, we should have applied the brakes 15 minutes ago. No. So if you do need to send data somewhere, we're going to have faster networks, increasingly faster, with 6G coming along. So this enables all kinds of fun games, high definition games and 3D video, gigabit per second internet, all kinds of stuff. But it's also going to enable this Internet of Context, data from all these different sensors giving us information about our environment, whether it's a manufacturing environment or a large construction site or a big thing like an airplane or something, wherever we're collecting data. Which leads me to the IoT, my Internet of Context, sensors everywhere, streaming data everywhere. Whether you have a wearable device like a Fitbit, so a health device, that is an edge collector, right? It's collecting data at that moment as you're exercising or whatever. But it's also about connected cars, connected products, precision farming, industrial Internet of Things, and so forth. I really like to think of it also as the power of one of these things on a global scale is for climate change monitoring. Okay, having sensors sort of measuring things in situ in real time. You know what in situ is, right? In situ. I gave a talk to my graduate students several years ago, and I talked about in situ data. And so this student of mine, when I had this question on the exam, he wrote in C2 data. And so I just read it. I didn't know what that was. So I asked the student, I said, what's this? And, nitrogen, carbon data? What are you talking about? And he said, you talked about that in class. I said, did I? He said, you talked all about that in C2 data. Okay. My bad. Didn't explain myself. I always blame the teacher. All right, so the internet used to be a thing. Now things are the internet. So I call that the internet of context. And it's everywhere, to infinity and beyond. I like to think that was in the Toy Story movie, but it actually wasn't. Anyway, but the thing is that just the predictions of the market value in both edge computing, which is the computing we're doing on those data we're collecting, but also just the embedding of sensors in environments where we're giving observability to businesses, to manufacturing plants, to large assets like airplanes and things of this sort, and visibility into things like climate change, where we have sensors in environments, all kinds of things like this. Just for an example, my wife's family decades ago bought some property in upstate New York, Adirondack Mountains and Lake George, which after my mom and dad-in-law passed away years and years ago, my sister and her sister inherited the property. So we go up there every summer. We've been going up there every summer for 50 years. And we're in the north part of the lake. Anyone who goes up to Lake George, we're in the north part of the lake, so it's more isolated from the crowds at the south part of the lake where all the fun stuff happens. Anyway, so we're walking, last summer we were walking along just up a creek. We were up a creek without a paddle. We were walking up this creek, which was feeding into the lake, and there was a little sign there with all kinds of wires and a transmitter and stuff going into the water. And I said, what is this? So I walk up there, and it's an Internet of Things project from Rensselaer Polytechnic Institute. And it had a whole description of the sensors of the nutrients in the water, the bacteria in the water, all kinds of stuff in the water, sensing that. And apparently they have many of these sensors around the lake, and they're sending the data back to the university where the scientists are monitoring this, called the Jefferson Project. You can look that up. And so I said to my wife, read this, you'll know what I'm doing now. Because she always says, I don't know how to tell people what you do. You had a career as an astrophysicist, a career as a this and that. And I said, no, I've only had one career. I've had many different jobs, but I've only had one career, and that's as a scientist. But read this, you'll now know what I'm talking about these days. IoT, Internet of Things. So massive growth in the years ahead, and I really love this quote at the bottom, comes from an article. They said, IoT companies will dominate the 2020s. Is your resume ready? Good question. Okay. This is the Internet of Context. Now what context gives us, again, I said before, those insights that enable better decision making. So what really is decision making? Well, decision making is sort of two things. One thing, it's predictive analytics. All right, you make a decision based upon what you think the outcome is going to be. Right, I'm going to drive to UMBC this morning this way instead of that way because I predict I'll get here faster. Or I'm going to order this instead of that because I predict I'll find more value in this product than that product. So a decision is a prediction. But it's more than predictive analytics, it's prescriptive analytics because you want to optimize the outcome. You don't want just any outcome, you want a better outcome. You want an optimized outcome, all right? And so getting all this context that gives you insights. Now, if your IoT, if your sensors have APIs on them, then you can tap into these sensors and identify trends, anomalies, okay, emergent phenomena, depending upon what you're measuring in your sensors. You get these insights in this context. So you get context as a service. I call this also forecasting as a service, insights as a service, intelligent edge as a service. Okay, I got a little carried away there. But you really can build businesses around providing these kinds of insights to businesses. And this is one of the things that our group at Data Prime has been working on, is working with companies around the world, certainly supply chain and logistics companies particularly, have been collecting tons of data about where their cargo is going and when it's arriving, but they're just collecting the data. They're not really like making any sense out of it. They're not really deriving the insights. They're doing very simple forecasting, but not much optimization. All right, so you can understand the difference between optimization and predictive analytics. Predictive analytics says, given X, I can predict what Y will be. So given X, find Y. Optimization is the opposite. Given Y, find X. Here's the outcome I want. What do I need to do to get that? Okay. So optimization asks the question, what is the optimal outcome? Not is what do you predict is going to happen? So, for example, predictive maintenance in machines says, hey, your jet engine is going to fail 3,000 feet above the ocean tomorrow. Wait a second, can't you do something about it? Just like I go to the doctor said, you got this problem, okay, not good for you, here's my bill. And then I say, well, wait a minute, can't you do something about it? Okay, so a prediction is one thing, but you really need to have a optimization, a prescription for something better. And so the insights and best decision making, like I said before, is not tunnel vision of what's right in front of me, but what's the context in which all this is happening. Okay, getting that contextual information gives me the best insight into what's going on. All right, so we talked about a lot of things on this list. I say one more. Looking at my clock time here. I got a big clock up here that's telling me how much time I got left. And I'm going kind of fast because I actually wanted to tell you a story at the end. I wasn't sure I was going to get to the story, but I guess my mouth is moving fast enough that I might actually have time for that story. Okay, so it's not in the slides. Where's Jason? It's not in the slides, Jason. Sorry. So let's talk about this one, though. Autonomous Dynamic Data-Driven Application Systems. Okay. So I first heard about DDDAS many, many years ago when I was at the university, George Mason University. It was probably almost 20 years ago. Frederica Darima, I still remember her name. She came, Dr. Darima, she came from the Air Force Office of Scientific Research, AFOSR, Air Force Office of Scientific Research. And they had this program called DDDAS, Dynamic Data-Driven Application Systems. The original website's come and gone. They got a new one, which is the one, dddas.org. Don't go to the other one. I think it's taken over by someone now, and bad things happen if you go to a pirated, hijacked website. Okay. And what she talked about was this paradigm of 4 steps towards that data to insights to action that way I talked about at the very beginning. Okay, so the 4 steps were labeled MIPS. I don't know if they still call it that. When I go to that website, I can't find anything that talks about that. But that's what she talked about, and it always stuck with me. Measurement, inference, prediction, steering. All right, I gave a talk about this topic to one of our Navy clients years ago when I was at Booz Allen, particularly at the Patuxent Naval Air Station. I got to this point of the talk, and the guy said, excuse me, this was some Navy pilot, he said, that's the OODA loop. I said, what? He said, that's what the pilots call the OODA loop. Observe, orient, detect, and act. Or, no, observe, orient, observe, and act. Same thing, observe, your measurement. Orient yourself, that is, get the inference of what's going on here. Okay, decision. What did I say earlier? Decision is a prediction. And then you act. And steering means just basically steering your resources, actually taking the action. So I really love that he told me about the OODA loop, because I like to use the word OODA loop in a sentence as much as possible now. It just sounds so cool. I had OODA loops for breakfast this morning. Anyway, so measurement, any kind of data, inference, these are the things that we do, inference and prediction, that's our data science steps, machine learning and data science steps. So I sort of blend those two, the I and the P, together here. And then the steering part, the S, is where we actually take the action. We derive that value from taking action. And so we're trying to do this now through the things I talked about this morning, these emerging technologies at the edge, bringing intelligent edge to our operations, okay? Augmented, assisted, accelerated, amplified intelligence at the point of data collection, at the point in space and time of data collection. So I call that event science, okay? Being able to triage things. Do I respond to this? Don't I respond? How do I respond? Okay, so it's basically using AI as a triage mechanism. As you collect something, what do I do? In the same way a medical first responder does triage in a situation, we're doing triage with our data using our AI. Okay, that's event science. So part of event science is the word science, which I like to say, what is science? But it's the process of learning, right, of learning. You test and experiment, and what we're testing and experimenting is the best thing to do. That's what predictive analytics and classification is all about. Finding the best solution that optimally predicts the outcomes. All right, that's the science part. Okay, so there's all that validation step and training data and all that kind of stuff. Okay, so that's event science. So the future is you. So the title of this talk has something to do with the future of AI, so I need to get that in here for you. The future is you. So what do I mean by that? Well, I already talked about the value of collecting data at sensors for global sustainability. What I like about this is if you've ever gone to or maybe heard of or gone to the United Nations Sustainable Development Goals website, they have 17 goals, all right? So you can read those: no poverty, zero hunger, good health, quality education, gender equality. Those are great goals, but how do you do that? We all can sign up for the goal, but where's how you do it? All right, well, the cool thing is they got these 17 goals, but if you look deeper into the reports, they actually have clear objectives, actually things you can measure, over 230 of them. I call them KPIs for the world, okay, key performance indicators for the world. Things you can measure to determine how well you're doing against these goals. And so how do you measure something? Data, all right? Measure stuff with data. Put sensors in the right places to start measuring against those KPIs, those 230 things there. And I think if we're not already, a lot of places in the world, we're going to be holding companies and countries accountable to these KPIs. Like, how well are you doing against these things? You have to, and if anyone ever did the Six Sigma training, it's about saying what you're going to do, doing it, and then proving it. Okay, and how do you do that? Collect data to prove you're doing it. All right, so it's all about the data to proving you're doing it, not just saying you're doing it. All right, so I think that's one thing we can really think about, how we use all this stuff for greater good. And if you just pick one of those, that's still a thing to do. Then I got this list of 10 amazing AI achievements in the next few years. I'm not going to read this. You can read this. The slides will come later, I think, but you actually can just look this up. I want to get to my story, which I'm going to get to now with a few minutes to spare. So I'll put this slide up here as a placeholder, but I'll say what the slide says here. So as data scientists and data science and AI practitioners, I'm going to read this to you because I don't want to get the word wrong here. We are explorers, okay? So we're exploring vast and endless seas of data with this passion to discover solutions to challenging problems. That's what we do. We want to inspire other people in the same way to do this, right? And I love this quote from Antoine de Saint-Exupéry. I think he was a shipbuilder and a poet. He said, if you want to build a ship, you don't just drum up people and get to gather wood and assign them tasks and work. What you do is teach them to yearn for the vast and endless sea. That is, you show people something, what's out there, what can they discover, what is there to discover, what is the endless unknown that you can go discover. Then they will want to go to gather the wood and do the work assignments. So this is what we need to do to build AI literacy and data literacy, is to inspire people with the big goals. Yeah, I'm a mathematician at heart, scientist by training. I love algorithms, I love numbers, but not everyone does. So I can wax eloquently about algorithms all day long, and it's just not going to work for some people. Okay, so you got to tell them more than just the number story. You got to tell them the personal stories. So I'm going to tell you a personal story. So it's the first time I've shared this publicly. So last summer, I started seeing a doctor, a new doctor, because I changed jobs and I had to get a new primary care physician. And he listened to my heart and said, you got something wrong there. Your beats are all wrong. So he sent me to a cardiologist. And through the fall of last year, I was taking all these different tests, getting different pills, and doing all kinds of things. And came to the conclusion that something needed to be done to figure out more deeply what was going on. So I had a catheterization scheduled, which is where they go in with the scope and check you out. Before that happened, 5 months ago, tomorrow, January 5th, 5 months ago, I woke up at 4 o'clock in the morning, and I told my wife, something's wrong. So we went to the hospital, and I'm going to brag for them, Adventist Healthcare, Adventist Hospital in White Oak. If you ever have a problem, that's where you go. They're not paying me to say this, but I swear to God, go there. So I get there. The guy who was scheduled to do my catheterization just happened to be there that morning. I mean, the one that was scheduled that didn't happen, but he was there, so we did it. I don't know if you ever had a cardiac catheterization. They do it while you're awake. I said, no way, you're not doing this to me while I'm awake, Mr. Nervous Wreck here. But they said, oh yeah, we put you on, we give you some drugs so you feel kind of loopy. And they did, and I felt loopy. But I was wide awake during the whole time. And during that procedure, he said something, and then he explained it to me later when I was less loopy. He said, Mr. Borne, you should not be here. I said, what do you mean? He said, your LAD, you know what that is, right? And I said, the lower anterior descending artery. He said, you know what that's called? And I said, yeah, I know what that's called. My father died of a heart attack 50 years ago. 2 weeks ago was the 50th anniversary. My father died of a heart attack from that artery, and it's called the widowmaker. I know what that is. My mother was made a widow with 3 boys in her mid-30s. And for 50 years, I wondered, am I going to have the same thing? My father died of a heart attack. He said to me, your LAD is 100% blocked. That's what the guy said to me, January 5th, 5 months ago. Your LAD is 100% blocked. You should be dead. You should not be here. But somehow, through some miracle, your arteries figured out how to get oxygen to your brain. Well, I don't know what your faith is, but I claim the miracle there. Somehow, I was still alive. They did the surgery, found 2 problems in there, big problems. One was something I've had since childhood I didn't even know about, a bad valve. They replaced that. They did the bypass surgery. I went through months of rehab. I graduated from rehab 2 weeks ago, and I'm on my feet. But why am I telling you all this besides just to tell you a personal story? Because something that happened to me when I came home from the hospital 1 week after that surgery. And it was just like boom. Sometimes things just like boom to you, right? My wife and I come home. This was January like 12th or something. It was one of those cold, extremely cold winter days in January. And I'm not going to tell you the rest of the story about my recovery in ICU was worse than hell. And I'll just leave it at that. It was the absolute worst experience ever in life. I get home, so glad to be home. And when I walk in the house, it's like, wow. Everything was like vibrant. Like, whoa. I mean, it just knocked me across the head. Like, what the heck? I just couldn't believe it. I said, is this the same house? So I was sharing this story with the founder of Data Prime, where I work, letting him know that I'm okay, and I was talking with him, and he's a former Air Force pilot. And he told me this story. He said, you know what? Let me tell you a story, and you'll understand what happened to you. He said, when we were in pilot training at the Air Force Academy, one of the exercises they do in pilot training is they want to put you into an oxygen-starved chamber and let you experience hypoxia, which is let your brain experience oxygen starvation. So you know, they do that so you will know what your own symptoms are when it happens to you. They're not trying to kill you, they just want you to recognize your own symptoms when it has happened to you in a real flight situation. And he says, so they were sitting around this chamber, a sealed chamber, someone speaking over the loudspeaker, the trainer giving them instructions. And at one point in the instructions, they were just sort of sitting there, and just the various pilot trainees were looking at each other saying, okay, what's going on? You know, just sort of like curious, suspicious, is something going to happen eventually, you know? And the trainer comes on the loudspeaker and he says, reach under your chair. And I said, I want you to pull out something that's on the lower part of your chair there. Sort of like in kindergarten, you know how the little places you put things on the chair. And they pull it out, and it's a color wheel. And they said, I want you to look at the color wheel. Okay, we're looking at a color wheel. Okay, what's the big deal? And they're looking at this color wheel, and then sort of in an instant, the colors just exploded off the page. I mean, they were just like, everyone in the room gasped. All of a sudden, the colors came alive, just boom, bright greens, bright oranges. The colors didn't change. The oxygen going to their brain changed. And for me, I had cognitive signatures the last 4 months of last year that I did not realize I was experiencing. I was getting contextual data. I had all those lab tests. All right, remember I said, you're looking at the data that's right in front of your face, like the self-driving car, but you got to look at the context. And my context was I was losing interest in work. I couldn't concentrate on things. I couldn't get things done. I was turning things down. That's my living, freelance, right? I couldn't focus on things. I just couldn't get it. My brain was oxygen starved, and I didn't know it. And by some miracle, I lived to get back to my house with full oxygen flow to my brain, and my whole house was like that color wheel. And it taught me, and after I went through my rehab, I promised the people, because those people saved my life and actually brought my life back to even a better state than it was ever before. I said, I promise I'm going to tell this story, because if anyone is experiencing anything close to that, do something about it. It may save your life. So thank you for listening. Now, if you can't read the words fast enough here, one of my favorite quotes from Isaac Asimov, famous science writer, he said, the most exciting phrase in science, the one that heralds new discoveries, is not eureka, but that's funny. So I'm wishing you many funny encounters with your data. Now, I don't know if we have time for questions or not, or what the plan is, Jason.
Yes. So we forgot to do this during the intro. So this is obviously the mic that you're going to ask questions on. If you want questions, just come up and line up. We have a couple minutes if there's any questions. I'm not going to walk the mic to you, so you have to come to the mic. Is there any questions you want to come up?
I think I've stunned everyone into silence.
Okay. Well, we can give Kirk a round of applause.
Thank you.